We are going to do a brief lesson today, talking about what a vector is and just some basic operations. We are not getting very far with vectors, just the basics with those. In general, a vector is a directed line segment. So basically, it looks like a ray. If you've had geometry, you've seen rays before. That's what it looks like. They can be written different ways. We are only talking about what's called the position vector today. And that'll actually be all we cover in here at all. A position vector is a vector that starts at the origin and ends at a given point. So if I said the vector is -2, 4. Okay, all that means is you have a ray that starts at 0, 0. It ends at -2, 4. And the only difference is it has an arrow on the end instead of just a point. Okay, that's what a vector is. Notation, we'll see they're usually named with a lowercase letter that's bolded. So this is vector U. Has an endpoint of AB. We are talking about three things with our vectors: magnitude, direction, and then some basic operations. Magnitude is the length of this. Now really, that comes down to, like, you could think of it as a triangle and do a squared plus b squared equals c squared, right? So the magnitude, or the length of a vector, it looks like an absolute value here. That's the notation for the magnitude. It's just the square root of a squared plus b squared. It's just if you were solving the Pythagorean theorem for side C. The direction is finding the angle associated with it. If I were trying to find this angle, then you could use tangent. Tangent is opposite over adjacent. My opposite height would be my B, my adjacent height would be my A. So the direction is the angle where tangent of theta is equal to B over A. Those are the only two calculations we're doing with these. Ultimately, it's no different than if you were to draw a triangle and find those pieces of information. I will also have those on your formula sheet. So they're things that we've already know. We're just doing the same thing with a different terminology associated with it. So if I asked for the magnitude and direction here, the magnitude is just the square root of a squared plus b squared. So my a is 3, my b is -2. If I plug those in, we just get square root of 13. Direction. That's finding the angle. You could think about this first. What quadrant would this end in? We're talking about 3, -2. That's quadrant 4. Okay, that's going to be helpful for me when I try to find my angle. So to find my direction, we know that tangent, if you're using your formula, it's just b over a. Or you could think of this as a triangle. Here's our angle, opposite over adjacent. How do we get the angle by itself? What do we have to do? Tangent inverse. Remember, we always do the reference angle by doing the positive. So make sure you're in degree mode. So tangent inverse of a positive 2/3. Get 33.69. And we've already established that has to be in quadrant 4. So if you do 360 minus that, get 326.31 degrees. Any questions there? So like I said, it's really, if you drew triangles, stuff that we've done before, but on any test, I've got a little, on our formula sheet, vectors, and I've got the magnitude and the direction stuff right there. This next piece is if I asked you to write the vector, if I gave you the magnitude and the direction, could you write the vector? And those are sometimes called the horizontal and vertical components. Horizontal is just like your x value, your y is your vertical component. And it's just taking the magnitude times the sine or cosine of our angle. Okay, again, that's really just related to setting up a triangle. If you were trying to find a certain point, this for my point that I was looking for here, that's my vector. And so I would have to be able to find these A and B values to get there, right? And so you could work backwards from sine and cosine. The hypotenuse is your magnitude side, the length of that. And so we know that cosine, bless you, is adjacent over hypotenuse. So if you multiply over the hypotenuse, you get that for your A. Sine is opposite over hypotenuse. If you multiply that magnitude over, you get your B value. So that's where it comes from. Again, I'm giving you that on your formula sheet. It's just the notation for vectors. So, if I said that vector W has a magnitude of 25.0, so that's my magnitude. My direction angle, so my angle is 41.7 degrees. If I want the horizontal and vertical components, I'm just asking you to find the vector. So the horizontal, we have 25 cosine of the angle. Think cosine is the x on the unit circle, sine is the y. And so your y would be 25 times the sine of your angle. So if I want to evaluate, plug that in. You get 18 points. Let's just go one significant digit. That's all I give you in the problem. So 18.7. Questions so far? Just a couple more. So the next one, I gave you pictures, and I want you to write each of the vectors. So I have three different vectors represented. Vectors U, V, and W. So if I wanted vector U, my magnitude is just the length of this, which is 5. Cosine, what's my angle? So then that would be 5 sine of 60 degrees. Cosine of 60 is 1/2, so 5 times a half would be 5/2. Sine of 60 is radical 3 over 2. So 5 radical 3 over 2. Vector v. What's the magnitude of vector v? 2. Cosine, what's my angle? This would be 2 sine of 180. Okay, cosine of 180, you could even think on your unit circle. Or you could think about like 0 as a reference angle. So the cosine of 180 would be -1. So 2 times -1 is -2. What's the sine of 180? 0. And doesn't that make sense if I'm looking at this vector? Doesn't it end at the point -2, 0? Vector W. What is my magnitude? And my angle? Okay, so we just plug those in. So I get 1.0419. -5.9088. Any problems writing vectors? So magnitude is just the length of it. It's like Pythagorean theorem. To find the angle, you can use tangent. And then writing the vector, it's basically just like on the unit circle, cosine or sine, times the radius is essentially what we're doing. Last piece then, vector operations. We can add, subtract, multiply, and divide. All we're going to talk about is adding, subtracting, or multiplying by a constant. And it's exactly what you think. If I ask you to add two vectors, you add the x values together, and then you add the y values together. So, if I gave you this one, u plus v. So, to get our vector, we add the x values together, so we get 2. V, so we add our u plus v. So to get the y's, we do 1 plus 3, which is 4. So when we add those, we get vector 2, 4. Okay, the only difference is to show their vectors, it's like those little, it's not a parenthesis. Okay, use that symbol there. -2u, what would you guess that means? So I take vector u, each piece times -2, and we get 4, -2. All right, last one. We have to do pieces. How would I find 3u? First vector times 3, which gives me -6, 3. Minus 2v, so the next one times 2. 8, 6. So then to subtract these things, we just subtract like pieces. So -6 minus 8. And 3 minus 6. Any questions about that one? Last problem. Sometimes vectors might be written in terms of other vectors. Okay, I'm saying vector u is the opposite of vector I plus 2 times vector j. Okay, whatever vectors I and j are, we don't know. But if I ask you to find 2u plus 3v, essentially all you're doing is combining like terms. So what's vector u? Plus 3 times v, which is I minus j. distribute. We get -3 right there, and then like terms, so we get I plus J. Right, so we don't have to know the actual components. We can just add like terms. So V minus 3U, V is I minus J, minus 3 times mu I plus 2J.